Good morning, good afternoon, good evening to you, wherever you are joining this live stream from, or if you're watching the replay, you're in session 4 of CICD Summer School. It's session 3 because we started counting from 0. I'm your host, Michael Jenkins, and I'm glad to be speaking with you today. I'm glad you could take the time to join me today for another session of CICD Summer School. I am a LinkedIn Learning author. I produce courses on CI/CD, DevOps, software development, things of that nature. And I just enjoy sharing these topics so much that I wanted to do something outside the band of a course on LinkedIn Learning and take a shot at live streaming. So here we are with this session of CI/CD Summer School. I am joining you from Southern California, and I want to know if you're joining us live, or if you're watching a replay of this, you can drop it in the chat. Where are you joining the session from? So, like I said, Southern California. If you've been joining us in the previous sessions, then I've had like a beach background for my background screen. And it wasn't a beach in Southern California. So I was like, you know what? Let me give a shout out to the area that I call home, the South Bay of Los Angeles, and use a picture of one of the beautiful beaches that we have here as my background. So what you're seeing right now behind me is the Manhattan Beach Pier in Manhattan Beach, California. Not too far from where I live. So at the end of this pier, there's a building called the Roundhouse. And there's actually an aquarium inside that building. It's really cool to go out there in the mornings or really the evenings to catch the sunset, as this picture kind of shows here. But to go out there and just kind of see the waves coming in, see the sun setting into the west and the Pacific. Catalina Island will be out there. You could see it. You might even catch some dolphins, surfers, boogie boarders. It's really a interesting and beautiful place to check out here in Southern California. We also have some folks joining us in the live stream. We got Tyree joining us here from Northern California, Oaktown. Good to have you here, Tyree. And we also have Frosty joining us from, I mean, it's not frosty right now. It's not cold, but Minneapolis, Minnesota. Not necessarily a little known fact, but I went to school in Iowa at Iowa State University, just south of Minnesota. So I did have the opportunity, plenty of chances and times that I took advantage of to spend time in the Mall of America just outside of Minneapolis. So really enjoy having folks from the Midwest joining the chat. Looks like we got LinkedIn user. I can't see your name, but I'm glad you're here joining us from Orange County, right around the way. That's literally right down the 405 for me in Newport Beach. So I'm glad that you're joining us here today as well. Thanks so much, everybody, for joining me today in the live stream. Before we get into the meat of this session, let's start with some resources from around the way. So in this segment of CICD Summer School, I'm sharing resources, content creators that I follow, podcasts that I listen to, and other resources that I tap into to hone my craft. I find them useful, and I hope that you will too. So let's get right into this from around the way. Oh, and LinkedIn user, I'm glad you cleared yourself up, is Thomas Wong. How you doing, Thomas? Me and Thomas, we were at Top Golf earlier this week, whacking some balls right there in El Segundo. So good to see you, Thomas. Thanks for joining the stream. All righty, let's get into what we got here from around the way. So in the last session, I mentioned that I would share ways that you can get LinkedIn Learning for free. And so just like the banner here says, LinkedIn Learning for free, question mark, yes, for free. Because I mean, it's one thing for me to say, hey, check out this course on LinkedIn. You know, I've got this catalog that you can select from, Nginx, GitHub Actions, Bitbucket pipelines, and so on. But I know that I may be doing some of you a disservice if you don't have access to LinkedIn Learning. Maybe your company doesn't pay for it. Maybe, you know, you can't pick up that subscription right now, or whatever the case is. So I wanted to share with you a way that you can access LinkedIn Learning for free. And I've known this for a long time. I should be sharing this more often. I have to give another shout out to Samira Dolan because she does this on almost all of her live streams. So I definitely want to share it with you all as well, the way that you can get LinkedIn Learning access for free. So let's get into it. And it's your library. It's your local library. Now, I will preface this by saying not all libraries provide access to LinkedIn Learning, but a lot of major libraries, metropolitan areas, larger counties, they use taxpayer money to provide the service to their constituents. So I've got the big one here on the left here, the LA County Library where I live. They provide access through their digital program to LinkedIn Learning. If you are in Chicago, the Chicago Public Library also provides LinkedIn Learning access. And then if you're in New York City, the New York Public Library also provides access to LinkedIn Learning. So again, if you're in Minneapolis, Oakland, Newport Beach, check in with your local library, get that library card out. If you don't already have one, sign up for one, and then check into the digital programs that your library offers. And hopefully, more than likely, you can find access to LinkedIn Learning through your library. And basically, some people will say, or they'll do the search, Google search, oh, I need LinkedIn Premium for free. LinkedIn Premium does come with access to LinkedIn Learning. However, it's usually, if you get it for quote unquote free, it's usually for a limited time, maybe 6 months, maybe to a year. If you get access to LinkedIn Learning through your library, it's for free. You get the entire catalog, you get everything, and it's for a lifetime, right? So don't discount your local library and the services that they offer. Get that library card out, dust it off. If it's digital, I guess, blow some of those bits off of it, and log into their portal. See if you have access to LinkedIn Learning through your library's digital services. So that's number one topic from around the way, carry over from the last session. Okay, get into this next one. And I'm really, really hyped about this. BitCon 2024 is coming to Atlanta, Georgia. Now, if you're not familiar with BitCon, it is the international conference of the Blacks in Technology Foundation. Blacks in Technology, founded by Greg Greenlee many years ago. I can't even remember now. But their their goal is to stomp the digital divide between African Americans and people of color and their access in technology. In addition, to tell the stories of people who work in technology to let the community know, to let everybody around us know that yes, we too can make it in technology. So I've been a member of Blacks in Technology, my goodness, since 2013, maybe 2014, somewhere around there. Um, and I've also been a speaker at every single one of our international conferences. Actually, shout out to Minneapolis, Frosty, because our first two conferences were right there in Minneapolis. And we've moved around in different cities. We've been to uh, Orlando, Florida. We've been to Nashville. We did some virtually. And this year, 2024, we're going to my hometown, Atlanta, Georgia. So I'm really hyped, really excited about that. I've got the link there, the QR code there. I hope that you can join me, grab your ticket. And there, if you look at my LinkedIn profile, I got a discount code there. I'm not going to try to repeat it here because I forget actually what the characters are in the discount code, but it'll give you 20% off your ticket. So check that out. If you're really, really interested, catch me in my DMs and I'll slide that code to you post haste because, and I really want you to be there because, like I mentioned, I've spoken at all the conferences before, and I'm excited to have the opportunity to present once again at BitCon 2024. So in this particular session, and let me kind of gather my thoughts here. In the past, I've shared topics on CI/CD, of course, but also I've shared topics on live streaming. That was another impetus to me actually doing some live streaming. And my take on conference presentations, I enjoy going to conferences for the content, for the information that people share, right? But I also study the craft and the delivery, the content that people are sharing in their presentations. And my personal take on a lot of presentations that I've been to is that I walk away with, I don't know, I don't want to say nothing because I did get perhaps something out of the interaction, but I want actionable steps that I can follow immediately after I leave a session. So just know that if you come to my session, you're going to walk away with information, steps, and resources that you can use, you can apply right away to improve yourself, to improve your business, to improve your company, maybe even your community, maybe even the world, who knows. But in this particular session, I'm going to be talking about hosting large language models, also known as LLMs, for Gen AI use privately and for performance. So I can't give it all away right now because, like I said, I'm really excited. But that's the topic: self-hosting large language models for privacy and performance. So I sincerely hope that you can join me at BitCon 2024 in Atlanta, Georgia. Okay, let's get on with this. Let's go to the next segment, which is last week. So last week we were talking about rethinking, and actually we're not even going to rethink it. We're just going to stop using CI/CD tools. Excuse me. We're just going to not even use CI/CD tools at all. So you might be thinking, if you didn't join us last week or you didn't check out the last session, you might be thinking, why are you going to stop using CI/CD tools? Well, I mean, spoiler alert, we're not really going to stop using CI/CD tools. We're just not going to consider them as CI/CD tools. Instead, we're going to consider them as CI/CD frameworks. So the session, and actually in the session, we went over reasons why we shouldn't just call them a tool, a single use element for one purpose, because we get so much more from these quote unquote tools that we use, to the point that we probably should be considering them as frameworks, right? So the homework from last week was to compare framework configurations for the Hello World project that we're sort of using throughout this course, or throughout this summer school session. We had configurations for GitHub Actions, which is a YAML format. We had configurations for Jenkins, which is a Groovy format. And we also had configuration for TeamCity, which uses a Kotlin format. So just as a point of review, let's very quickly take a look at some of these configurations. Okay, so this is the repo from session 2 and kind of gives some guidelines about how to get to the code. And again, the configurations that we're going to looking at, starting out with GitHub Actions. Now, GitHub Action it uses a YAML format. Now, YAML is yet another markup language. It's used across a lot of different tools. You'll see it in Kubernetes. You'll see it in Circle CI. You'll see it in Bitbucket pipelines, and on and on and on. Just because it's easy to read, it's easy for humans to understand. It's easy for computers to understand. So it's a really good format to use for configuring systems. Now, one thing about GitHub Actions is they break out their pipeline stages into jobs. So you can really see um, the steps that take place in this particular job. And I don't have a graphical representation of this, but they do a really good job of showing the graphical representation of these jobs, these stages, and how they connect to each other. Like in this case, if we go to this line here, this delivery job, it needs the integration job. So it'll follow directly after the integration job runs. And then we see all the steps in here, and it kind of gives us an idea what's happening in these particular jobs. Moving on to Jenkins, it uses a Groovy format. It definitely differs quite a bit from that key value pair of YAML. It's much more of a I would call it more of like a it's like a program, almost like a programming language, sort of like a domain specific language, but it still looks like it has some configuration elements to it. Um, we don't get a clear sort of pipeline, we get that pipeline keyword there, but the graphical view of it's a little bit different from the GitHub Actions view, where we have these stages, or the stages keyword that define the stages of the pipeline. And then in the stages, we define each stage, and in each stage, we define each step. A stage can have multiple steps. And of course, as we see the stages, of course, it has multiple stages, but a pipeline, it has to have at least one stage, and each stage has to have at least one step. So you'll see that sort of, when I say format, follow through a Jenkins configuration. And again, same commands that we're running in the GitHub Actions. We're linting, we're applying or running our tests, and then we're delivering our artifact. These are pretty clearly spelled out here in the Jenkins pipeline. Now, a little bit different, and this is kind of the reason why I wanted you all to look at 3 different configurations, or configurations from 3 different frameworks, is the Team City configuration. Now, when you get this Team City, it's using Kotlin. Now, Kotlin is a cousin, a little brother, or something like that of Java, right? So it definitely has a programming feel to it. Like whenever you're calling package, whenever you're importing a library from somewhere else and bringing it into your runtime environment, that definitely gives me a programming feel as opposed to a configuration feel. And then on top of that, we're literally instantiating an object, right? And then we're assigning properties to or assigning values rather to the properties of this object. We're giving it a name. We're telling it what the artifacts are. We're giving this property of where the VCS root is, and so on. And then we also, very similar to Jenkins, we have the steps sort of a property, and inside that steps property, we have the scripts property, which actually implements all of the individual steps that take place in this particular pipeline. And you'll see all the commands that are very familiar to you by now, that we've seen in the other pipelines. So I just wanted to point out how these configurations, they all implement the same pipeline, but the formats are sometimes wildly different, right? So it's just interesting to know that we as automation practitioners, as CI/CD practitioners, really the tool or the framework that we're using, it's not the end all be all. Like, don't call yourself or don't assume yourself to be a Jenkins professional or a GitHub Actions professional or a whatever tool or framework you want to insert there. You are an automation professional. You're a deployment professional, and you will use the tool, the framework, the resources that you have available to you to get the job done. It depends on the environment, the element, the team that you're working with, and so on, of how you will proceed. So that was kind of the lesson that I wanted you to get out of that last particular session. So we're done with around the way. We're done with last week. Let's get into the meat of this session, deployment methods for every scale. Okay, let's get started with this. And I'm going to go right into the material here. So what we're going to do is we're going to review 3 deployment methods. And there's a lot of different ways you can deploy applications, right? This week, we're looking at all at once, rolling, and blue-green. And we're going to get into each one of these step by step. I also want to say that this is very specific to web applications or applications that have some sort of HTTP endpoint, some sort of network access to the service or to the application. Because again, as we mentioned, I think it might have been in the very first session, session 0, or it might have been session 1, which was the second session because we started counting from 0, that our deployment methods will vary based on what it is we're deploying, right? Code can be linted all the same, code can kind of be tested all the same, but when we're actually putting that artifact in place, deployment methods will differ wildly, right? If we're compiling a desktop application and deploying that looks a lot different than compiling a mobile application and putting that in place, or compiling and packaging a web application and putting that in place. So in this particular session with these particular deployment methods, we're speaking specifically to web applications that are accessed somehow over the network. So just wanted you to keep that in mind as we go through this. Also, we're going to be looking at some images, some graphics that I put together, and I've got some elements on there. I didn't label every single element on every single slide because it would get kind of busy, right? So I just want you to know going into these particular slides, if I don't mention it, that if you see these elements, if you see this cog here with the people around it, that's our DevOps team. That's our programmers, our developers, and the operators and SREs that commit code to a repository where the code is integrated and an artifact is delivered to some place where we can actually deploy it from. That artifact is represented by these little stack sheets here, and you'll see that represented as blue or green, with blue being the current version and green being the newer version. And these little cubes, that represents our compute, right? That's what we're deploying to. Now, I didn't want to have a server to let it specifically be a server. I didn't want to have a function symbol to show that it's a function, but this is like some sort of compute. It could be an ECS cluster. It could be a Kubernetes cluster. It could be, like I said, Lambda functions. Whatever the case is, I just want that cube to represent compute. So just kind of understand that. And then the colors, the blue and the green, that represents the current version or what's ever currently running in our production environment. And then the green represents the new version, this brand new green thing, this newer version that's coming in and being deployed. So keep those in mind as we go through these particular charts. And if you got any questions or any comments or anything, this is an interactive session. Feel free to drop them into the comments. I'll take a look over there every now and then. And if I catch your comment and can address it, I will bring it into the session and we'll talk about it. Okay, but for now, let's jump right into it with all at once. So again, this is sort of the layout that we have here. We've got our team, we've got an artifact or a version of our artifact, and then some sort of compute that's being run. This is ground zero. This is state 0, where we're starting from, right? So the next step is the team deploys a new version. And so this is the artifact or rather, they haven't deployed it yet. The team delivers a new artifact. So we have a new version of the application that's ready to deploy. And as you might expect from the all at once name, this new version is deployed to all compute elements all at the same time. And you're done. You're pretty much done after that. So now you have this new state where you have the new version and it's been deployed across all elements. So one thing that I failed to mention, that we're gonna discuss each of these particular deployment methods a little bit after we sort of walk through the steps that it takes. All at once, pretty quick, right? There's not too much involved with this. You get the artifact and you put it in place, right? But let's consider a few things when we look at this a from a reliability perspective, from an operator's perspective, and also from our consumer's perspective. That consumer could be a human on the other end of the line, typing in www whatever. It could be another service that needs access to this particular service to implement whatever function it needs. So keep those things in mind as we consider these deployment methods. So as we already mentioned, the all at once method, it's fast. It's going to deploy to every resource that you have in place, every compute resource, all at the same time, and boom, you're done. That's all there is to it. But from a reliability perspective, what if we need to roll back? Like, what if there's a problem with the deployment? What if we didn't catch it in our testing and then we've deployed a bad version of the application to everything? In that case, we might experience downtime. We might have to roll back. That rollback could be risky because now we have to figure out, okay, how do we get back to the last version and how do we deploy it out all at once to everything so we get the application back up? So with that, I'm going to say the rollback is a little bit risky with all at once. And I would say the scale for this particular approach is limited because, and scale, I'm looking at it in a lot of different ways. I'm not putting numbers on the number of compute. I'm not putting a limit on the number of users, but I just want to think about the scale in terms of like what sort of application or service would we want to use this deployment method on. I'm going to say this is limited. I'm saying it's limited because we probably wouldn't want to use this approach for an application that can't withstand some downtime. Like this might be for, we might use this approach for an internal application where we can tell, the few people or the few services that rely on our particular service, the one that we're deploying, that, hey, we're deploying. And so we're going to be offline for an hour or two. The service might be unstable for an hour or two. So they need to, to know that. And if it's small enough scope, small enough scale, then we can manage that, right? But if this is Walmart.com, or some sort of larger, if it's your email service, that particular scale might be too great for this type of deployment. I wouldn't want to do an all at once deployment to a service that can't withstand some downtime or that I can't control the access to the service while it's being deployed. So with that, I'm going to say the scale for this one is limited. All right, moving right on to the next one is the rolling deployment method. Now, rolling, it kind of picks up from the all at once perspective, but it tries to overcome some of those problems that we saw. So let's kind of walk through this one step by step. Again, we've got our trusty development team. They deploy a new version of the artifact, and we are going to, or rather, I keep saying deploy, you know what I mean? They deliver a new version of the artifact, right? And then we kick off, that delivery kicks off the deployment. And in the rolling approach, what we're going to do is we're going to want each compute element in turn deployed to it before we move on to the next one. So if you look at the bottom of the screen there, I'm counting the steps. So I'm saying this is step 2 in the deployment of a rolling deployment of n+1. So that n is the number of elements. So in this case, we have 3 compute elements. So we're going to have 4 technically steps in this particular deployment approach. So we'll just walk through it. We got in our artifact, we deployed it to 1, we deployed it to the second one, we deployed it to the third one, and then we're done. We're at our new step. So I'm going to go back 1 step here. This, as you can see, it kind of alleviates some of the problems that we had maybe in the all at once, right? We have a little bit more control over how we're rolling things out. And if we catch an error earlier, then maybe we can roll back from it a little bit easier. So let's get into the discussion here. Comparing the speed of a rolling deployment to the all at once deployment, it is slower, right? Because in the all at once, bam, it doesn't matter what the number n is, we have deployed to everything all at once, one point in time, and bam, we got a new version. Rolling is a little bit slower because depending on what that N is, right, we have to touch every single one of them. And so that could take some time, right? If our deployment takes 30 seconds per N, it's going to take or 30 seconds per fraction of N, right? It's going to take a minute and a half here, right, to deploy to all of these. And that might be too long for our application, to be in this sort of transitional state, right? So speed is kind of slow. Rollback, I say it's easy-ish, right? Because if we catch any errors or problems early on, then we could stop the deployment. Hopefully we have the methods in place to do that. But say, for instance, in this particular state that we have here, we deploy to node 0 in this particular list of nodes. And we say, oh man, this looks really bad. We should stop the deployment right away. We could stop it and we still got a couple nodes running up. But now we're sort of in this funky state, right? We've got one node that's broken running the old version of the code. And then we got two nodes that are up running the last version of the code. And so our application might be in some sort of funky state. Hopefully the application has the logic to withstand the sort of instability. But we've caught it. We hopefully can roll back, have that methods in place to deploy the last version to this particular node, get everything back up stable. So that rollback is easy. That's why I say it's easy-ish, right? We can catch errors earlier, but we still have to roll back to some sort of comfortable state. The scale, however, is unlimited, right? We can have as many nodes as we need to touch, and we will, we'll be able to deploy to them one in turn. Unlimited with the catch, right? Because if it's a totally large system with a lot of compute elements, we may not have the time to deploy to all of them. Again, like if it's a long deployment, some deployments might take hours. We can't spend days on end deploying an application, depending on the application's needs and the customers that we're servicing, right? So scale is definitely unlimited, but it kind of comes with some catches to that as well. All right, let's move on to the last deployment method that we're considering today, blue-green. Okay, and we've got some new elements on the screen here, so let me break these down a little bit from left to right. At the bottom of the screen, you see these compute elements that are sort of grayed out, right? These are compute elements, servers, Lambda functions. Maybe they don't even exist yet. I just want you to kind of keep them in mind that they are there and they are an essential part of this particular deployment. They could also be servers that are sitting, waiting to be used. Maybe they're online, but they're not configured yet. And they're waiting for that deployment to get kicked off, right? Next up, we have this purple sort of tetrahedron shape, this rectangular thing. That's our load balancer. And so the load balancer is directing traffic from any users, from any services that are accessing this particular cluster of compute, right? And that arrow that's coming up, it says, hey, right now we're in the blue state. All the requests that are coming in are going to be delivered to this blue cluster of nodes over here, and they are going to service any requests. So with that, let's kick off this deployment. Thank God that our trusty DevOps team is still hanging in there with us as we review all of these different methods, right? You guys, I got to hand it to you. You're awesome. They have delivered another new version of this application, and now we can kick off our deployment. So how does that work in this particular setup? Well, those grayed out sort of servers or nodes or whatever you want to call them that were just kind of hanging out there, we're going to bring them online and we're going to deploy this new code to them first. Actually, at all. That's the first part of this deployment. Bring those green, actually that's why it's called blue-green. Bring those green servers online, deploy that new version, and get that service or application up and running there. But if you notice, the load balancer, nothing's changed over there yet, right? We're still routing traffic to our blue cluster. So let's go on to the next step. So now that we have the green service up and running, it's healthy, everything's good, the trusty DevOps team, or maybe some services or infrastructure or automation that they have in place, they can use that to check out the green cluster. So they're doing their testing before these green clusters begin servicing requests to our clients, to our customers, to any services that need to access this application, right? So this is great, right? Because before we even sort of make this application live or this new deployment live, we can run all kinds of tests. We can stay in this particular state as long as we need to make things right. If we catch an error here, we can deploy again. We can deliver the artifact again to this set of compute. We can blow this compute away, deploy a whole nother set of nodes, and deploy a whole nother version of the application without affecting the blue cluster, without affecting the clients and services that need that service to be up and running, for whatever their needs are. So however long it takes, or whatever we need to do here, we've checked everything out. We have determined, and by we, I'm talking about our trusty DevOps team. Thank you guys for all the work that you've done. And they sign off and say, hey, this green cluster is ready to go. So we want to switch the traffic from the blue cluster to the green cluster. Let's do that in the next step. So now the load balancer is switched to the green cluster, and our clients, they're seeing this new version. They're like, hey, this is great. Next to no downtime, if any, because we did this switch, right? We're controlling the switch at the load balancer level. Some cases might do it at the DNS level. But in any case, the downtime or the visibility of that switch from our client's perspective is next to nothing. It's very, very fast, almost to the point where they probably won't even notice it. We still got some work to do, though. We're not completely done because we've got these blue clusters that are just sitting around, right? But the one thing that I will catch, excuse me, before I go on to that next step, this is also a good point for rollback, because we did testing in this step, right? That's not really live traffic. Sometimes when you bring an application online, you can test it out in a very quiet space. But once you bring it into this loud room where it's actually getting the stuff that it was intended to do, things change, right? So this state also gives us an opportunity to roll back to the blue in case we need to. And again, that switch is really quick, right? So if we get to this state where we're running live traffic to the application and we're like, hold up, wait a minute, this is not looking like we intended to, we can switch back to the blue pretty quickly, right? And then we can run our tests, we can fix whatever we need to fix, and then we can deploy again and get everything back to this state. Now, once everything's live and it's looking good, we can either decommission that blue cluster, we can let it hang around and get ready for the next deployment and just kind of rotate roles on these particular clusters, whatever the case may be. But we do have this additional step after everything is in this new zero state, where we got to do something with these particular, the blue cluster that we started with. So let's review. The speed is fast-ish, right? Because the actual cutover from the client's perspective is fast. They're probably not even going to notice that we deployed a new version. But if we stick in this particular state here that's currently displayed on the screen, we could be in this state for quite some time, depending on how long our checks take, any remediations that we need to make, or whatever the case may be. So in that case, the deployment could take a long time. We could set up the green cluster on Monday and not actually deploy the cluster, the actual, do our cutover until the following Monday. You thought I was going to say Friday. Never deploy on Friday, folks. I mean, maybe you can. I don't know, but I would wait until Monday or Tuesday, to be honest. So that speed could be fast for the client, but maybe a long time for the team or the automation that's actually doing the deployment. The rollback is going to be super safe, because if we deploy this new version, once it goes live, we find some problems. If we still have our blue cluster around, we can cut back to it very quickly, very easily in terms of the state of the application as well. And our clients are probably not going to notice too much of a difference there. I mean, if they were experiencing errors, they're going to notice when the errors go away. But for them, that switch is going to be faster than if we had to do a complete deployment of everything in the system. Now, the scale is unlimited. We could do this with a large number of resources. Again, just the approach that we're using, but we have to think about the cost as well because we're basically doubling whatever it costs to run our application for some period of time, right? If your blue green deployment takes an hour or two or less, then maybe it's not so bad. But if you are sitting on that week-long deployment because you're running tests, you're getting validated and certified and all these other cases, then you're spending some money, right? You're spending twice whatever it costs to run your infrastructure. So you also have to keep that in mind as well. Okay. And even Frosty joining into the chat here. Yes, no deployments on Friday. Let's please, from recent past experience, let's try not to deploy Friday at like 5 p.m., before people just kind of take off for the weekend, long weekend or whatever. Let's definitely avoid that if we can. Okay, let's take a look back at each of these real quick. In summary, all at once, it's fast because it doesn't matter what the N is and the number of compute. We get everything done all at once. But it's kind of risky, right? Because if we have any downtime, we got to go back, figure it out. We have to fix the problem. And in that funky kind of unstable state, our application is going to be like, what's going on? And we got to figure it out. And I say the scale here is limited because we don't want to have a blast radius that affects a lot of services, a lot of people, or if it's a service or application that we can't control. We want to keep all at once deployments to small things with limited scopes that we have much more control over. Okay, rolling, it's slow because if we have thousands of nodes or compute that we have to deploy to, it's going to take 1,000 times however long one of those deployments takes, right? But it's safer because if we see some problems leading up to the completion of the deployment, we can stop the deployment, initiate some type of rollback and take care of things there. Still a little bit risky because while we're rolling back in that error state, our application may be a little bit unstable. However, scale's pretty much unlimited, right? Depending on however many stuff we need to touch, we can do it. And if we're talking about scale in terms of what we have control over, the clients that are accessing our applications, we can minimize the downtime that they experience because we're not affecting the entire application all at once. Okay, and last but not least is the blue-green method. It's fast-ish. Fast because it's super fast for the client that's looking at our application because we're just cutting over at the load balancer, we're cutting over at DNS, but it could be slow for the team. It could be slow for the automation that's deploying the application because of any sort of testing or validation that we have to do before we actually do that cutover. However, it's safe because when we're doing that, or after we do that cutover, if we need to roll back, we can roll back probably almost immediately to the last cluster and get back to a known state very quickly with minimal, if any, instability. Scale's also unlimited. I would use this approach for applications that are widespread, have a large number of users, and so on, because once we cut over to the new version, it's stable. And as we talked about, the rollback, if we need it, is relatively safe. However, it can be expensive because we're doubling our infrastructure costs. Whatever it takes to run our application at the compute layer, we're pretty much replicating that entire configuration and deploying to those particular compute nodes. And that, depending on what you're running, some GPU-enabled AI system, it might be kind of expensive. So definitely keep that in mind as well when you consider your blue-green deployments. So that wraps up the lecture portion of it. Let's get into the homework. I want you to research one more deployment method, and that's the canary deployment. We didn't talk about that particular method in this session. Maybe we'll touch on it in the next session. But before that, I want you to do some legwork of your own. I want you to Google, go to your local library, perhaps, and look for resources that explain the canary deployment method. And then next week, we'll get together and we'll talk about it. I also want you to think about the methods that you're using today in your particular applications. Now, as I started the lecture portion, I know that a lot of these deployment methods, they have to do with web applications or applications that require some type of network access. So if you're building mobile applications, desktop applications that don't require these types of deployments, that's fine. But I also want you to think about, how is your application deployed? How do people actually get their hands on your stuff, right? How do they access new versions? Just think about the ways that you're deploying your application. While you're doing that, I want you to think about a different method that you could use. Like, just even if you've already gone through the exercise to say this is the optimal way, or you've inherited a system that's in the past says this is the optimal way, think about some different ways that you might deploy it. Just consider problems that you've had with deployments in the past. Think about things that you can optimize in your current deployment method, and see if maybe one of the methods that we discussed today might be a better fit for your particular application. And then also, I want you to think about how these deployment methods can be combined, because honestly, in a lot of enterprise level systems, you're actually going to be using a combination of these deployment methods. And I think we'll go a little bit deeper in that in the next session, when we review the homework for this particular session. I've got the QR code for the repo for this particular session. You'll see some demonstrations, some graphics of the deployment methods that we discussed today, along with some notes. Just review those to kind of help your research, and just, to kind of impress this idea into your consciousness. So as you apply them in your craft of automating, you'll be able to keep them in mind. And yes, Frosty, I wanted to include Canary, but I think Canary deserves its own focus, perhaps. And maybe next session we'll devote the entire session to deployment or Canary deployments, and combining deployments, because I think that's really cool. Because and honestly, like I say, if you're studying CI/CD, or if you haven't landed into your role as a CI/CD practitioner, more than likely you're going to see a combination of these methods when it comes to deploying an application, particularly one that gets a lot of access, a lot of traffic, or has a lot of a very broad surface. I'll say that. So we will get into the Canary deployment in the next session. And that brings us to the end of this particular lecture. I'm going to catch up on my notes here. Let's see here. Yeah, I think that pretty much wraps it up. First of all, I want to thank you all for joining me on a Saturday, same time, different day. It's summer, so we got a whole lot of things going on, and schedules change. So if you're joining me in the live stream on LinkedIn or YouTube, thank you for adjusting your schedule to join me. If you're joining us on the replay, it doesn't apply to you, but still, thank you for joining the session, for checking out this particular session of CI/CD Summer School. And if I didn't mention it earlier, I did want to say the last session, I had a typo in the bit.ly code. The QR code was correct. The bit.ly text was wrong in the particular session. But use the QR code if you need to get to session 2. I think I was supposed to put CI/CD sesh 2, and I put CD sesh 2. So anyway, typo. Hopefully you're able to get to the resources just the same. With that, I'm going to sign off. I got a lot of weekend ahead of me, and I'm looking forward to enjoying it. And I'm also looking forward to seeing you all right here again. We're still shooting for Friday at 9 a.m. So I haven't added it to the homework, but including your assignment to register for the next session once you see that announcement. So once again, thank you for joining me. Enjoy the rest of your weekend, and I'll see you next time for CI/CD Summer School.